Good day! Today, you're going to learn about prime factorization. But before that, let's just first differentiate prime numbers and composite numbers. Prime numbers are whole numbers that only have two factors, 1 and itself. Example, the number 2. Number 2 has only two factors, 1 and 2. Because 2 times 1 is equals to 2 and 1 times 2 is equals to 2 also. We cannot think of any other number that can be a factor of the number 2. On the other hand, composite numbers are numbers that have more than two factors in addition to 1 and itself. Example, the number 4. 4 times 1 is equals to 4. 2 times 2 is also equals to 4. Therefore, 1, 4, and 2 are factors of 4. Having 3 factors, 4 is considered as composite numbers. The prime numbers between 2 and 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 61, 57, 71, 73, 79, 83, 89, and 97. All even numbers greater than 2 are composite numbers, and all numbers that end with 5 and greater than 5 are composite numbers. But remember that 0 and 1 are neither prime nor composite. Now let's learn prime factorization. Prime factorization is a process of finding the prime factors of a number. Again, a prime number is a whole number that only has two factors, 1 and itself. It is important to know and learn prime factorization because it is used in getting GCF or greatest common factor, LCM or least common multiple, and can be used in addition and subtraction of dissimilar fractions. There are two ways to do prime factorization. First is by factor 3 or by decomposition method. In doing factor 3, you'll need to break down the number into two factors and keep finding the factors until all the remaining numbers are prime. While in decomposition method, you'll need to divide the number by prime numbers until the last quotient is also prime. This is sometimes called division of prime method. Let's put it into action. Let's say we need to get the prime factors of 36. So by factor 3, you'll need to break down 36 into two factors. We can use 2 and 18 as factors of 36 because 2 times 18 is equals to 36. Then because 2 is already a prime number, we don't need to break down it. We'll just need to break down 18. We can use 3 and 6 as factors of 18 because 3 times 6 is equals to 18. Then let's leave 3 because it's already a prime number. Now, the factors of 6 is 2 and 3. All the remaining numbers are prime. So to write the prime factors of 36, let's just multiply each prime numbers. So to simplify it, let's translate it into an exponential form. Because there are two 2's and two 3's, we can write it as 2 squared times 3 squared. Prime factors can be written from least to greatest, and exponents can be used when factors are repeated. Now, with the same number, let's try to get the prime factor of 8 by using different factors. So 3 and 12 are also factors of 36 because 3 times 12 is equals to 36. Then again, because 3 is already a prime number, let's just think of the factor of 12. 3 and 4 are factors of 12. And again, 3 is a prime number, so let's just focus on 4. Let's think of the factor of 4. 2 2 and 2 are factors of 4 because 2 times 2 is equals to 4. Now, let's get again the prime factors of 36 using different factors. 4 and 9 are also factors of 36. So let's just continue breaking down the number into two factors until all the remaining numbers are prime. So as we can see, even if we use two different factors, we can still get the same prime factors, which is 2 squared times 3 squared. Let's have another example. So here, we need to get the prime factors of 144. Again, we need to break down 144 into two factors. So think of two numbers that when multiplied to one another, will get the answer of 144. So we can use 12 and 12 as factors of 144. Then, let's break it down into two factors, which is 3 and 4. Because 3 is a prime number, we only need to break down the number 4. And the factors of 4 is 2 and 2. Because all the remaining numbers are prime, let's now write the prime factors. So we have 4 2's and 2 3's. So instead of writing it as 2 times 2 times 2 times 2 times 3 times 3, we can write it as 2 to the 4th power times 3 squared. So the prime factors of 144 is 2 to the 4th power times 3 squared. Remember that there can only be one set of prime factors for every whole number. Now, let's try to get the prime factors of 144 using decomposition method. So, in decomposition method, we need to divide the number by prime numbers. So, think of a number that can be used to divide 144 without remainder. Because 144 is an even number, it is divisible by a prime number 2. Let's just continue dividing the quotient by a prime number wherein we can get an answer without a remainder. Do it until the last quotient is also a prime number. Now, we've reached the last quotient, which is 3 because 3 is a prime number. To write the prime numbers using decomposition method, we'll just need to write the divisor of each quotient and the last quotient. So the answer is 2 to the 4th power times 3 squared. The answers that we get using decomposition method is just the same using factor 3. Let's have another example. Let's try to get the prime factors of 64 using decomposition method. Again, because 64 is an even number, we can use the prime number 2 as a divisor. So let's just continue dividing the number by prime numbers until the last quotient is also prime. Now, the last quotient is 2, which is a prime number. So the next step is to write the prime factors. Here we can see that all the divisors and the last quotient are just the same, so we can just count it and translate it into an exponential form. So the prime factor of 64 is 2 to the 6th power. Remember, in doing the decomposition method, the number should be divisible by the prime number or has no remainder when it is divided. Let's review. Prime factorization is a process of finding the prime factors of a number. Prime number is a whole number that only has two factors, 1 and itself. Composite number has factors in addition to 1 and itself. There are two ways to do prime factorization, factor 3 and decomposition. There can only be one set of prime factors for every whole number. Every composite number can be expressed as a product of prime factors. The prime factors can be written from least to greatest, and exponents can be used when factors are repeated. Now, it's your time to practice. Have fun! Thank you and God bless.